So welcome everybody. Thank you for joining us this evening. I'm Jason Dvorkin. I'm the chair of the SMPTE Rocky Mountain section. We're excited tonight to bring you this session titled Monitoring Video, Audio, and Ancillary Data in a Hybrid SDI and IP World. I'd like to introduce Joe Castellano from Leader, who will walk us through a presentation this evening. And Joe, I will turn it over to you.
Hey, Jason, thanks for having us. We're excited to be here. We've been doing this SMPTE, we call it the Roadshow. Basically, we started out in New York and sort of growing and getting the word out, and been doing this for a little while, so we have a nice presentation put together. Helping me out with the presentation is Steve Holmes. I'll let him introduce himself. He's our guru. He's our engineer. And also on the line is Tony. Tony is the West Coast representative for Leader. In the chat section, I'm going to put all three of our email addresses so you can reach out to us if you have any questions going further. At this point, I'd like to give it over to Steve. He has a nice presentation. If you have any questions, please raise your hand or butt in. We'd be happy to help. We want to make this as interactive and friendly as we can. So Steve, thank you.
You got it. Okay. Hopefully somebody chime in if you see my screen, because this Zoom's...
You are good. We see PowerPoint in slide view.
Good. And then
Not
you should see... get the right one. Hang on. Another. Yep.
Yeah, we got the waveform. Yep, fabric.
Yeah, but the wrong one.
Okay.
There we go.
That's the Leader.
Yeah. Okay. Just want to make sure all the pieces are piecing here. So I want to thank you folks tonight. Just give you a presentation about IP and SDI and working from the SDI world into the IP world from possibly a little bit different perspective, more from what tools are out there, what tools especially Leader has for the day-to-day operator, not necessarily from the engineering side of the house, and how to keep things simple and go through what we need to deal with in this stuff. The other thing we need to remember is that IP is just another I/O interface. It's just another way to get video, audio, and data from a switch and get it to the destination that we want to do or want to use. It's just how we do that has changed. It is that I/O pipe that has changed and what we need to deal with to get that I/O pipe to do what we want. In SDI, video, audio, data, all of that's on the same coax. So when we plug in the one coax, we have all the Hank data, we got all the Vank data, we got all of the data, i.e. captions and the like, that we've put up in the Vank, and it all just magically appears on that one coax when we hook it together. Well, in the world of IP in 2110 especially, we've taken that and kind of broken it up a little bit to where we don't send things that you don't need. So for video, all we send is the raw raster of the video. We don't send the horizontal interval, vertical interval. In the data world, we only send the raw data. So we don't send the entire vertical interval. We just send the data that you need. If you're looking at time code, if you're looking at captions, that's the only data that you're going to get. And in the audio, we're only going to send the audio and not the rest of that horizontal space. We're just going to send the AES 67 audio. That is the AES audio in what we've got. So SMPTE has taken this and broken it up into three sub pieces of the 2110 standard: the -20 section there is the video. It defines the video. And it's a multicast video. So we have the source address, destination address, the RTP header, and then all of the video payload that's going to carry all of the video data. The same for the audio. We've got the source address, destination address, RTP header, and all of the audio data in there. And then we've got the data channel, which is all of our metadata, our captions and alike. These three flows then make up the program, but it's going to be sent as three independent IP flows. You know, if you remember kind of back to the old analog days, we could take a oscilloscope and we could actually hang an oscilloscope on the coax and actually see the video. And a lot of people did it that way. And when we came out with SDI, that didn't work anymore. So we had to come up with new tools to be able to take those 10 bits of data to make a pixel out of that, take all those pixels, put them together, and either make a waveform or make a picture on the screen to be able to look at that. And likewise in audio, we could hang, you know, in analog audio, you can throw the oscilloscope on the audio and you can actually see the audio bouncing back and forth. Well, we've had to come up with new ways to get all of this out and about to us. So, you know, the SDI carries the audio, the captions, and everything else that we want. Well, we've done it again. You know, we've moved things around. We've changed things, like we did coming out of analog into SDI, coming from kind of SDI into the IP 2110 world. We have those three different independent flows that will make up everything. And since they're three independent flows, there's different things that can actually happen in going through here. There's always the IP troubleshooting tools. So there's an entire engineering set of tools that the engineer needs to be able to get in and dig deeper into when someone within the facility, the users, turn around and find an error, say something's not working right, to be able to look at packet flows, be able to look at packet jitter, look at PTP, which is our timing perspective for the IP, and look at buffers and a whole bunch of other stuff. But that's really not what you need to look for everyday day-to-day operations, because your day-to-day operations really haven't changed. So we still need to look at vectors, we still need to look at waveform, captions, possibly SCTE-104s, look at audio, look at loudness. That part has not changed. It's just possibly how we access those pieces that have changed. So for the engineer, there's a whole boatload of engineering tool sets that engineering needs to know about to set things up, to fix problems. But let's face it, for the everyday operator, you still need to be able to go into waveforms, still need to be able to go into vectors, still look at pictures, still look at audio. And those top four are still going to be the main piece of what you're still going to want to look at when you're looking at this stuff. If you look here, one of the beautiful things that some of the newer technology gives you is the ability to be able to put in an SDI view and put an IP view right next to it on the same waveform monitor and bring those two in and verify that everything that should be in the picture from the SDI side going into IP is there. Because let's face it, a lot of what we're going to get into in the early days is going to be encapsulation of something that we may have in the plant in SDI. And we need to be able to get in and out of SDI, and we're going to be doing that in most operations for many years. So as we roll into IP, it's not going to be 100% slammed through the facility if it's an existing facility. We're going to start off with this little piece that is IP, and we're going to take some of our SDI, and most of it generally starts with kind of around the switching and the routing, and looking at that and making sure that everything flows through that part, and being able to bring up the status windows that make sense for SDI, looking for CRC errors and looking for stuff that's screwed up in the SDI field, and be able to look at the IP status and make sure that, yes, I have my video flow, my audio flow, my ancillary data flow, and everything's coming in. But beyond that, let's face it, we want to be able to go out to the scope, look at waveforms, look at picture, make sure we've got captions there, possibly look at a vector scope, maybe look at the ancillary data and be able to see all of this stuff and be able to see everything on one screen and not necessarily tied to this has to fit here, this has to fit here. That, you know, I've got 4 different things up, but they aren't necessarily specific size windows. Be able to put things where you want them, how you want them for the job that you are currently doing, and then save that off as a preset so that you can bring it up and even look from the details here that, yes, you know, I've got my VITSI, I've got my payload ID, my 708 and 608 captions are there, and any other data is there that I have to have in order for my system to turn around and work. So one of the beautiful things, at least about the leader scope, is it has these multiple windows that are all drag and drop windows, and you can have about 40 different windows on the screen if you're crazy enough to put them on there, and actually size them, drag them, put them where you want them to be, so that you can make a view that possibly may look like this, to where you've got a status display next to a picture, next to a vector scope, and be able to look at this stuff. The other beautiful thing is being able to look at multiple inputs at the same time. On the particular scope I'm going to be using for this demonstration here is we have 4 inputs. Those inputs, each one can be assigned to an SDI feed or can be assigned to an IP feed. And the way I typically do it here is I generally take SDI1, SDI2, or take input A and B and assign them to SDI. I take input C and D and assign them to the encapsulation of those 2. So I'm running my SDI into an encapsulator, make an IP out of it. I take SDI2 and run that through an encapsulator and make IP out of that, and that way I can see the 2 flows side by side next to each other. And being able to see those flows next to each other allows you to set up specific screens and make sure that everything is happening and you see it visually rather than trying to look at some data flow. And if things are working correctly, you can put 2 pictures next to each other, and if you notice from the data here, here's my SDI-A coming in, here's my SDI-C coming in, or my IP-C coming in, of the same flow, and something happened here. I'm looking for captions in both picture views, but somehow the captions got stripped out on my IP flow, which is something that can happen very easily since the piece that I'm making here, this actually takes 2 different IP flows. I need an IP flow that's going to be my video, but my captions are on a separate IP flow. And if they don't get encapsulated or they get munched in the encapsulation, you may end up with a problem where they don't show up correctly. But the beauty is, for the operator, he can see it right off the bat and see what is going on in here. Likewise, you might want to add a waveform to this and be able to see the same thing, that I don't have my captions running. You can, since you can design these screens however you would like them, you can see that the captions are definitely not happening on the second IP flow here and what's going on. So if we just take a quick jump over to my scope here, we can see that if I look at my SDI input, I've got captions running. Everything looks like it should. But if I just walk over to my C input, all of a sudden, I don't have captions anymore. And the nice thing is to turn around and be able to recall a simple preset and be able to take and view those two right beside each other and definitely see that, hey, my captions are not making it through my system right now, and be able to go back and then tell engineering that, hey, we got an issue here. And if you just want to look at it from a picture view, we can turn around and just look at pure pictures and see whether or not my captions are doing what they're supposed to do in here and how things are working. We also have the ability, I don't have it in this file that I am playing out, but the ability to put up your your view of, you know, your V-chip data and see what the rating is and make sure that all the ratings are coming through. And also SCTE-104s you can place on the screen and be able to look at them side by side. You can see a commercial be tagged on your SDI, and if the commercial isn't being tagged on your IP, again, you can see it visually without getting into a huge data hunt, trying to look at many different things here. And be able to, like I said, be able to look at what's coming in from my SDI side here and see that, yes, my 608 and 708 captions are running here, but if I just walk in and change inputs, or I can just bring the ANTS data screen up by itself and walk over to my IP input and see that it's just completely missing, and it's very easy for the operator to say, hey, captions just aren't there, you know. And if you're supposed to have any other AFD or any other data in there, to be able to see that it is actually in fact missing and be able to ID this stuff very quick and very simple. Like I said, we do have the ability to throw up the V-chip data and be able to tell you on the content advisory what is going on, and be able to look at that in both pieces, be able to look at SCTE 104 splices and get the ID, the pre-roll, the break, and actually log those off also as things are going, and makes it very easily when you can just visually see it rather than trying to look at a data flow to see that things are in there. You can, you know, put up the SDIA, look at the waveform, put it right next to the IP of that same waveform. You can throw a little thumbnail on the screen if you want to have a little thumbnail on with your waveform at the same time, so you make sure you're looking at the correct data, and just confidence that, yes, that is the input that I think I should be looking at as I go through all this stuff. The same thing can take place with audio. We can look at and give you multiple displays to be able to look at the audio. And in this case, I'm looking at a 5.1, so I've got my left to right, my center, my left surround, right surround. And when I go look at my IP side of the house, I've got my left, right, and my center, but my surround channels are completely muted. So the surround channels never showed up in what was going on in what we were trying to look at. Go to something here real fast. So likewise, here's my SDI-A coming in, here's my A input, here's my C input. And you can see from the live view, so this is actually right off the waveform monitor, that I do have my 5.1 channels coming in, and I only have, well, 3 of the 4 actually going out, because I'm not getting much LFE action out of this particular feed, but you can definitely see that it is not there. And moved around, you can also see that something's going on here where I do have an issue in the SDI side. For those of you that might have caught it, this should have been center, this should have been LFE, but on the IP, it is correct. So that's even more of a weird thing, that somehow the channels got swapped when it went over to the IP side over here. That thing's happening. But again, being able to just see this easily visually and be able to look at things. And like I said, we do have the ability to look at 4 inputs simultaneously. So I've got my SDI-A, my IP of that SDI, I've got my SDI-B and my IP of that input also, and be able to see all 4 on the screen at the same time. And if you just want to see the picture of all 4 of them, we can turn around and just view just the picture, or I could just view the waveform of all 4 of them and just give you the ability to walk around and see it how you want, or drop out back into a quad, or just pop back into a single input at a time, and then be able to walk through A, B, C, or D very, very quickly, very easily. So the operators still operate the system very much like they would for a regular operation in your house. The other unique thing is we've gotten into a situation to where your video and your audio aren't tagged together as far as on the same transmission path. They are 2 different IP flows. So you have your video on one IP flow, you got your audio on another IP flow. So we've introduced another thing that could give us a AV delay, that the encapsulation and then the placement of where that audio belongs when it's recovered doesn't necessarily show up correctly. And in this case, I'm actually doing on the SDI side, but it's actually doing all 8 channels that I'm looking at simultaneously, so I don't have to go through a pair at a time. And my SDI is coming up absolutely dead on. So we have this little color bar with this little white bar that pops up, and then these are frames, how many frames off is the audio or video when it pops up, just so you can visually see it as well as actually measure it. And then when this came out of my encapsulator as is natively, it turned around and came out advanced by a little bit more than a frame. And advanced is never the direction that you want audio to go. If audio is going to do anything, you want it to come late. just because you or I have it ingrained into us to accept audio that always lags video, because if you and I are standing 50, 60 feet away from each other, the audio is coming in fractionally behind what you're visually seeing from the other person, but the brain accepts it and says it's normal. And I was able to turn around and use the adjustments that were in my encapsulator and turn around and bring that in. Now, the one thing that you're going to see on something that's digital, especially in IP, is I have to change this by IP packets. So it's not going to be quite as smooth and as granular as you might be used to in the analog world. This thing is going to jump from here to actually jump to the other side of 0. So I chose to take 4 milliseconds on the delayed side so that it definitely wouldn't be visible, let alone that's only a fraction of a frame of difference. And again, you can see I had all 8 channels coming in on the SDI side, and my encapsulator, for some reason, is cutting the other 4 channels out and not allowing them through. So it's another issue that's very easily picked up and seen. The other unique.
Steve, hey Steve,
Go ahead.
let me stop you for a second. There's a
Sure.
question that
Yeah,
came in. Where'd it
please.
go? Do you support UHD or HDR content on the waveform monitor?
But of course,
Yeah.
yeah, no issue at all. Both SDI and IP. We can go into that. We've got a little bit of time at the end. I'll actually jump into some of that. But yeah, we have the ability to set up each input independently. Just walk over really fast here. So I can set each input to any input you want it to be, as far as wrong mouse. I get the right one. So you can be turn off, and then you're just pure 709, HLG, PQ, all of the camera logs. And then if we go to any of these down here, it will follow the payload ID. So if the payload ID says what it is, the scope will automatically switch. If the payload doesn't, it'll go back to 709. Now, one of the unique things is, in the world we're at right now, I'd say probably 3/4 or more of the videos that come in don't have HDR tagged correctly in the VPID. So it's actually easier in the IP world under NMOS to actually tag it than it is with a VPID at the moment. But we do have that capability to be able to do that. And then input rates. Have all of the different 2K rates, SD through dual link, and then all the 4K, the different 4K rates that it can be 12G through quad, through IP, and IP quad or IP single stream, which is the mimic of the 12G. So no issue with either one of those in the scope supporting that.
Thank you.
Certainly. Pop back. So the other unique thing is, since PTP is our timing source for our IP, we need our IP and our SDI timed together so that they know where each other are and they are in agreement with each other. And one of the unique things that happens is we are only sending this green payload part of the video. Time from Blackburst and PTP starts right here, right at the beginning of the bank. And so we need to make sure that that starting point and the starting point of my video matches the starting point of my SDI video, so that when you're cutting from one source to another source, whether it comes in IP or whether it comes in SDI, those cuts are perfect and there's no jitter up and down or left right between the cuts. So what you're going to see, if you are a 1080i input, your video actually relative, so my PTP to RTP, because PTP starts at the same place black does, is it should be 21 lines later. So my video should have a offset, a line offset, a vertical offset of 21 lines, so that the active video of SDI starts at line 21. And my 0 point for PTP needs to be at the 0 point of my black burst. So we can use the timing display that we would use in SDI to also check our timing of our PTP and actually check to make sure that my PTP source is in lockstep with my NTSC black burst in this case. Or it could be tri-level, but in this case it was black burst. And I'm basically 0 by 0, so that my PTP is starting at the correct point also. And the best way to actually do this is have the same SPG, the same sync pulse generator, generating all of your black and tri-level and all your SDI test patterns, and also generating your PTP for you, so that those are all locked together off of one oscillator, and they don't drift, they don't move, they're perfectly in lockstep with each other, and that way you'll have no timing issues. We already took a quick glance at this. You know, it's nice to have just a quick data view of, hey, what's in the stream, is it there, isn't it there, without having to go through necessarily a look at, okay, I got to go down to this DID, this SID, this DID, this SDID, and see if the data is there, just to get a quick, simple English representation of that. The other thing that's kind of handy is, for those of you that have ever tried to make sense of a VPID coming in, you'll know that the VPID is actually coded in binary. These 2 bits mean this, these next 2 bits mean this, and then there's 4 words that fill the whole thing out. And what we have done is turned around and made a decoder ring. I'll show you in a second. But again, here's, you know, being able to look at things side by side and look at those ANTS data windows, and you can actually see my VITSI, my time code's missing, and my captions are missing. So coming out of my IP in this case, everything except for my payload ID is about the only thing that made it through the system. The rest of everything else somehow got stripped. Here's the VPID, and so here's the SDI coming in and saying what it is, that it's a 1080 3G level A progressive stream coming in for the SDI, but what was created from the NMOS, when the NMOS dropped it in, the NMOS said, hey, it happens to be interlaced. And generally the scope can figure that out and actually display it just fine and not have to worry about what it is and generally display it. But when we remake the SDI, because we'll take the SDI and the audio and put them back together and actually make SDI back out the back of the scope, so that you can go up to an SDI picture monitor and you can still see this. And you don't have to go switch monitors when you're looking at SDI or looking at IP. The scope will make the IP into an SDI flow out the back of the scope, and you can look at it. but it's going to signal that flow as interlaced, even though it's a progressive flow, because that's what it was told to build the new VPID that we're now inserting into the SDI stream. And that can screw things up to no end going out the door, because that'll make your monitor in most cases go nuts. So kind of taking this one step deeper here and looking at things. So looking for transmission problems. We're taking hits and you're getting glitches in the picture. In SDI, we look at CRC errors, cyclic redundancy checks. That means that the data has gotten corrupt. And looking at those CRC counts will tell us, yes, I'm taking data hits in the SDI world. In the IP world, we have to look at RTP errors. So that's a RTP continuity error. And RTP errors are very much like continuity count errors in MPEG. It is the same thing. It is a counter that every packet should increment the count. It's just a much larger field. It counts higher than just 16, 0 to 15, 0 to 15, that MPEG counts in a transport stream. But it's still the same thing. So each packet should have a increasing count. And when you don't, we have the ability to actually show where those IP miscounts are. And if it's miscounting, that's a dropped packet. Now, in SDI, if we have a CRC error, the data may still be there, but it just may be coming in as a different value. And it's only 1 pixel. And 20% of the pixels in SDI are off the screen. They're part of the vertical interval, the horizontal interval. So you've got a decent chance it'll never be seen if it's not a high, super high error rate, because you're only changing the value of a pixel, and it's only a single pixel, and it's on and off the screen so fast you'll never see it. We have a whole different thing happening here in the IP world. So the thing in IP is for 1080i video, 1 IP packet is a quarter of a line of video. And the way switches work and alike, if they get an errored IP packet, they throw the IP packet away. They will not transmit or not propagate errored IP packets. So if you take a single hit, you're going to screw up a quarter of a line of video. How receivers deal with that quarter of a line interruption is drastically different. So every receiving device is going to deal with that differently. You may get a snap in the picture where there's a quarter of a field offset. You may get white lines in the picture. The picture may go absolutely black. And it varies by what receiver type you are looking at. So you really need to get to know how this receiver responds. So this is actually a picture from a receiver that took a hit. And right in here is where it took a hit in the video. And you can see the video shifted because it dropped 1 whole packet. And all of a sudden, the entire video shifted left because of that absence of data. And from that part to the bottom of the picture, that data is missing because everything is shifted up and left. And poor Lady Liberty here got herself whack-a-dood. And the base is sitting over here, and she's sitting over here. This happens so fast, and it happens typically on multiple frames, that it looks like just scrambled video. But if you could freeze it, like I was able to, this took me about 10 minutes to capture one, doing a capture on an error, to grab just a single snapshot of that frame. This is what that individual frame actually looked like. but you could imagine with video snapping left, snapping back, snapping left, snapping back, and going back and forth, it looks like it's pretty torn up. Another receiver, for the same identical error, got these little white stripes all through it and just didn't know what to do without the data and ended up with these white stripes all through the picture here. This is what I think the majority of the receivers unfortunately do, is you take a hit and that picture is going to go black from the point where that hit actually happened. So if the hit is halfway down the picture, from that part to the bottom of the screen, it's going to go black. If the hit is near the top, because you have slid that line by a quarter, and now all of the sync, the TRSs and this that are the equivalent to rebuild the picture because they still exist, are in the wrong place, and it doesn't know what to do, and all the data from that point to the bottom of that frame is all in the wrong place. It's got to wait till the next frame of video to be able to put it back together and be able to do something with it again. So one packet can be really devastating in IP. It's one of the reasons we're using 2022-7, which is the one-for-one packet picking. So we make two flows of the same exact data go into a packet picker, and it just looks at both sides, and if it drops a packet on one side, it just grabs the packet out of the other side. It's one of the reasons we're building these duplex networks. So to give you kind of a big picture quickly here of what's happening, so I've got good data coming into a switch. I've got no packet errors leaving that switch, but all of a sudden something happens. Either the output gets corrupted, the SFP dies, the SFP gets dirty, gets misaligned, and you get errors going into the next switch. So yes, I have packet errors that are coming into that switch. You will have no packet errors leaving that switch. And you'll have no packet errors in the next switch. But you do have that missing packet. And the only way to count that is with that RTP counter, because the CRC errors that you can see on the input don't exist anymore because the packet went away. And one of the reasons we drop packets in IP is because the error could be in the address field. And the last thing you want is for IP data to mean something completely different than what it was. In the case of video, little Johnny may be watching his cartoons right now, and all of a sudden you take a data hit and it changes the multicast address field, and all of a sudden Johnny gets a whoo channel and goes running to Mama asking, "Mommy, what's going on?" And you know, that would not be too good to have happen. The same thing like, you know, money transfers, stock market exchange, any of these things. We don't want bad data to come out because we don't know exactly where the error is, so we've got to drop the packet, get rid of the error so it's not propagated. In most things other than video, because it is live and there's no place to resend the data, but in most other protocols there's ACKs and NACKs and we can resend the data. HTTP does that. Most file transfer protocols will resend the data if the packet is missing and the receiver doesn't get the packet it thought it should. So what we need to do when we get that data hit and we see the errors coming up here is we need to turn around and look for those RTP errors. And you will see those RTP errors flow through your system, just like you'll see continuity errors going through an MPEG system. And there is a method to be able to track those errors down and be able to see that you are, in fact, taking those errors and be able to report and see where those things are. So I hope this little presentation here, which was rather quick, but I just wanted to get out the fact that, from the operator still needs to be able to do what they're doing and be able to see things how they're used to seeing it. Still need to be able to look at pictures, still need to be able to look at waveforms. But being able to, if you are a hybrid house and have an SDI and IP, to be able to bring those two inputs in and be able to see them side by side when they have a problem that they think they've got on their IP, rather than making them absolute 100% IP jocks from the beginning, and be able to just look at it and say, hey, here's my SDI coming in, here's my IP, and you look across them and see it. Makes things incredibly simple, incredibly easy for your normal operators to be able to deal with things. To be able to look at timing and make sure that your PTP and your SDI, your IP and your SDI are both locked to the same clock. The unique thing about IP is video is always a synchronous network. We need to know where the frame is. You need to be on, the same frame as the source when you're displaying this data. IP itself is asynchronous. So we're taking synchronous data, throwing it through an asynchronous transport, bringing it back out using PTP to make it synchronous again at the other end. And to be able to see, multiple viewer screens and be able to set things up. So if anybody has any questions, I'm more than willing to answer them, but I hope you've gained some insight and some information from this presentation.
That's awesome, Steve. Thank you so much.
Yeah.
All right, Jason. So if there's any questions, feel free to either, I don't know, if you speak up or put them in the chat.
Yeah, speak up.
Quick question for you. What have you guys seen in the way of integration? So let's say I had a playout system for automation. Can I integrate your previews, your waveforms into another application?
Yes.
And is that all just API based? How does that work?
It is API, and everybody's API varies. Our particular API for that type of stuff is SNMP.
Okay.
Sets, gets, and then also looking at traps. But the beauty of this, there's very tight integration going on now for router panels. Everybody's kind of come to a level playing field that they're taking the existing router panels and controlling an SDI router on this particular source, but going over and sending an SDP file if it's this source. And so it just depends on which source you're going to, but it's the same data coming out of the routing panels. They've made the InMOS registration be able to pick that up and then send the SDP file, which is the the source and destination, where you need to go file for this. And they're making it work very well. There is growing pains, and it does take a bit to get them working, but when they work incredibly well. They're seamless side by side.
Thank you.
Okay, if there's nothing else, our email addresses are in the chat. You can reach us through Jason if you didn't copy those down. But it's been a pleasure being in front of you guys for this little bit of time. If you need any questions, like I said, please reach out. And if anybody's going to NAB, please stop by the booth. We'll be happy to show you the hands-on product.
Yeah, and if you want any more presentations on anything, I've got detailed presentations on PTP, on a lot of things, on the leader America YouTube channel. So all you have to do is look up Leader America YouTube channel, and there's a whole host of YouTubes up on that channel. So I want to thank you, gentlemen, for this opportunity to be able to present this for you.
Awesome. Thank you guys for taking the time to join us this evening. We greatly appreciate it. We'll get the video of this posted for anyone who is unable to attend. And we hope to see you guys at NAB.